Namaste. Namaskaram to all of you.
Namaskaram, sir.
In the syllabus, I saw something on probability, but I think the basic probability combination of cases in which you conduct experiments in tossing a coin, throwing a dice, from the pack of cards, selecting something, all that is look at the number of chances by the number of occurrence, independent occurrence. That is how the probability is defined, and we have dealt with it to some extent in the basic probability classes. I thought as management students, one of the concept generally which is very strongly required in learning in the case of business students is how well in the testing cases or quality control or understanding of the distribution functions in the case of probability normal distribution function, and how is it varying from the normal as a continuous function when you represent the probability functions. So what is to be understood here, there are three types of, generally the major three classes when we talk about a sample for which you can find an average, or in mathematical term it is called mean. When you take a number of samples, add them together, divide by the number if it is individual number, or if it is a frequency. Frequency means some item can occur many number of times. Then you have to consider it as frequency. So add all the frequencies, summation of frequency. If it is only numbers, add all the numbers together. So total number of occurrence and what is the outcome in the sample. Divide that by the number of occurrence, you get mean. In the median and mode, what is median? Assume you take the sample between 0 to 10. Identify the center, and from there both sides, how is it distributed? That is what you find out as median. And then you look at maximum number where it came in the, if it is frequency domain or the number, look at which occurred maximum number of times. These are three methods of identifying what we generally call colloquial terms as average, but in statistical terms mean, median, mode. Look at the definition, understand this, take some sample, compute all this, and then check how do they relate. Now we are talking about a case where median, mean and mode become same. In such cases, if you look at the distribution function, that's called a distribution function, how the data is distributed. If median, mode and mean is at the center, it will look like a bell shape. If it is a very good sample, that means extreme end of not having any frequency or having the highest number or the lowest value. As you go away from the mean or median or mode, the distribution is almost like dying out, zero. But in the center where median, mean and mode becomes the highest peak, so it's like a bell shape, a distribution function which is like a bell shape. That is what is called a normal distribution. It is also called a Gaussian distribution because the person who did this was called Gauss, Frederick Gauss, yeah, that's his name. If in a normal distribution, what is called the binomial distribution, in the natural case, only two-dimensional x-axis and y-axis, you draw a curve. There are great mathematicians like De Moivre and Laplace, and all those people did a lot of research on this in the early 1970s, and they found that the distribution in the two-dimensional function, as it goes away from the center, as it goes away from the mean median mode, the distribution function will fade out, and that science was developed as to understand what and how a sample will behave, and if it goes too much of peaked in one side, like the curve becomes a D shape sort of a thing, that is measured as skewness. Skew means change of shape, and kurtosis. These are all higher statistical. I don't know whether that is part of your syllabus. You must look at the syllabus and ask me so that I could explain it further. But I am throwing some light in whatever I felt is required. So minimum binomial distribution, as a management student, you are supposed to know. As in the x-axis, as you goes to 0 to infinity, at 0 and infinity, at both extreme end, it becomes taper out to be 0. In the center, where the mean median mode will become, it will become a peak. That distribution is called standard distribution, normal distribution, and bell shape of distribution, where that variation from the mean, suppose mean mu is the mean, and then identify what is, how much is it away from the mean, each value. So you have a sample of 10 numbers, find out the mean, from the mean find the difference from the one, and that variation is called a sigma square generally, and standard deviation is square root of sigma square variation, that is sigma. That is how you generally fit a curve, that's called a root mean square. If you take and then put a straight line, you get a straight line with a all the distribution are very close to that line, then you say that sample is a very good sample. If some samples go away from the line, then we say the sample is not good. That is how sometimes the least square fitting, that topic is called the least square fitting, line fitting. From the average, how far is each parameter varies. And if you put a straight line, you know all that is connected where the variation is too less, it will fall on the line. If it is not falling on the line, then you must know that it is far from the mean, and that variation is called the variation from the root mean square. That is considered as sigma. So now what do? Assume you got a sample, some quality product. You must identify how much it has closeness to the quality. The quality is the mean, median, mode, maximum number should become the best quality. So how far is it away? How far is it away from the mean? That is identified with the shape of the curve. Now assume you have a beautiful sample. Then what will happen? The peak will be 1. The distribution will be like this, how I am showing my hand. Suppose the sample is too bad, then the bell curve will start expanding like this. That means your peak will come down. As you expand, this peak is too high. You can see my finger on the tip is the peak. The peak is too high. And if the sample is not good, it will distribute like this. Once it distributes, the peak will come down. That means in the center, the frequency is very less. In this case, frequency is very high. So distribution function is very close to the mean. From the mean, from the average, from the median, from the mode, it is not too far. If the sample is not good, it will be distributed like this. So the peak in the bell shape, like the pyramid, from the stack sort of a thing, like a pillar sort of a thing, it goes into a flat terrain. That's how the shape of the curve. So looking at the shape of the curve, you know the distribution is too far, the frequency is less. Here frequency is more. It's like wavelength. In the wavelength, the distribution is far, wavelength is more. Frequency will become less. It will get dampened. The frequency is more, then wavelength will become less. The distance between this will be the wavelength. So very, very close. So if it is too far, it will be like this. So looking at the frequency curve, we know whether the sample is good or not. In some cases, this is what is expected. Assume that the number of occurrence of some event, when you look at it, everything is happening in the same style. That means it is very good. Suppose a political party getting elected, every vote goes to this person who is at the middle. Not many people are away from that. But this is not a continuous distribution, so you cannot make that. So assume that there are 2-3 different parties for which it is distributed. Then what will happen? The total number of votes will become less. The frequency will become less. It gets distributed. It will be like this. But if some party is getting maximum vote, it will become like this. The rest of the people will have only very less. So which is away from the mean? Only few. That sample is very good for this purpose. Analyzing this. Suppose there is a quality. Some item which laddu which you are making. Look at the weight of the laddu. Some maximum number of laddus are supposed to be 200, maybe 50 grams is one laddu. So every item will be 50 grams. There may be something which is 49 and maybe 39, 30. So they will get distributed here. Suppose something is above 70, 60, it will get distributed here. Suppose you take on the x-axis as the weight, and how many such laddus are coming is the y-axis. That is called frequency. So if few laddus can go away from the main expected outcome. Expected outcome is everything should be 50 grams. If it is distributed bad, then you are not a good producer. So the quality of the product, the quality of the producer, the quality of the sample which you are analyzing is identified by the distribution function. If it is like this, it is very good. If it is like this, it is not very good. So how is it identified from the shape? How is it identified? You will have to draw a bell curve sort of a thing, and then x-axis maybe your number of the item, maybe the weight of the laddu you can write. On the y-axis, how many laddus are there? So assume that there are more than 500 which is generated. In the center, the best number of laddus which are 50 grams happens to be 250. Rest of the things are distributed like this. So it's like a bell. Now how do you know the parameter which is to be associated, which says your here mean, median, mode happens to be exactly same, because distribution is like a normal curve, well distributed curve. It's like a binomial distribution sort of a thing, which you have got a beautiful curve like this. Okay, it's not no skewness, no kurtosis, no undesired behavior. Everything is perfectly like a curve. Now look at what is to be done now. Now at some point away from the peak, you take a small interval, and then that interval on the x-axis you project it to the curve. So you get a shaded portion. Look at the shaded portion between x equal to mu, the median mode is at the center. Little away you mark A and B, take a small interval, take it to the curve, so you get a shape. And that shape, when you look at it, you know, oh, This is the area of the coverage. The area of the coverage under the curve on the x-axis. Under the curve on the x-axis.
Sir, we are unable to hear you, sir. Sorry, not there, sorry.
And there was one network problem, that's it. So when you have a curve like this, on the x-axis you take from the mean x equal to mu, you move a little bit a and b, take a small interval, project it onto the line, so you get a small area. The area will be on the bottom side, it will be a straight line, left and right it will be a straight line, on the top it will become like a curve. Identify that area. That means you are taking a small strip out of the curve, the bell sort of a thing. You are cutting a small piece where x equal to a and x equal to b. Find out the area. Exactly what should happen in the distribution is very good. At this bell shape, you cut it across, take the right half or the left half, the area should remain same. So either you take from the left side or right side, it is very good. It is same, one and the same, no difference. Now, in a very good distribution, normal distribution, what is the quality? If you have a peak, take from the peak, take the left side or right side, area remains same. Now, if you take a small strip of between A to B, either from the left side or the right side of the peak, the area remains same. That's the beauty of normal distribution. That means your distribution sample data set which you are looking at is perfect. Okay. Now, instead of A and B taking from one corner, what you do is take it at a regular interval. From the center, you take +1 and -1. How it is distributed close to the center. Suppose this is the data. Assume you take -1 and +1. What will happen? Assume that you are taking a -1 and +1. Little away from the distribution function, little away. This is the center, take it little away here, little away here. Identify this small interval. All what the distributed, if you add it together, the area, that will become the total frequency because it's all concentrated in the center. That means what? All your ladoos are made almost 50 grams. Maybe 51 grams is possible, 49 grams is possible. But less than 49 grams, more than 51 grams, there are no ladoos at all. That means the ladoo maker is a beautiful, wonderful, very good ladoo maker. So, if you look at a small interval and compute the frequency, how much portion of the total number of ladoos you made is coming within very close to the quality of the product what is demanded, which is coming very close to the quality of the product which is demanded. That means every ladoo has to be 50 grams. How many ladoos are close to 50 grams? How many are away from 50 grams? If many are away from 50 grams, the curve will be like this. So if you take a small portion and then look at the volume, the area below the curve, that will become, say, normally the data has to be, your distribution function has to be, your quality of the product has to be very good. Such qualities are only you are assessing. Suppose it is 60%. That means the best laddu is 60%. 40% laddus are bad. Assume you have a curve in which when you take the area, 80% is within that. Then what do you say? So there are two companies. Company A produced all laddus very close to 50 grams. Company B produced all laddus only 60% coming in the middle. Then you have to give some quality standard marking, name, some parameter to tell the company A which produced better laddu than company B. How do you do that? Weigh all the laddu. Suppose it is quality, you will have to number the quality and then give a distribution function. Suppose the number of dolls produced by some company, they have a quality check and you put marking all the qualities, some company A and company B. How do you know the company A is good? Take the statistics. That is what is statistics. You look at the quality and check whether all the qualities are coming in the required, what you expected, very close to that, whether the distribution function is like this or like this. Now the shape is only when you can look at it. How do you give a mathematical number, mathematical quality expression for the mathematics and then tell that this is a better product than this? That is why you make a curve, look at the area. If the area under the curve is very close to the mean, that means your standard variation from the mean is not much. Everything is very close. That each individual number you have to take and add. Instead of that, what is done is the normal distribution function is drawn. Look at the area under the curve and then if that area happens to be, now assume that you divide the whole thing into number of portions and then look at it 1/3, 1/3, 1/3. Look at the area. Now there are some numbers created. Suppose if the area is more than 90%, more than 70%, more than 60%, more than 90% is close to the mean means the peak is like this. That's a very good case. Suppose it is like this, it is 60% only good. Then it is not a good sample. That is how it is mentioned. These numbers are generally in statistics called any guess? Anybody knows this? It is called, anybody? Sigma is the normal word used for standard deviation. Sigma square variance. So mu is the mean. Mu minus sigma less than x less than mu plus sigma. The mu is the center, sigma is the variation. So probability of mu minus sigma less than x less than mu plus x or sigma plus mu. Okay, probability of mu minus sigma less than x less than mu plus sigma. That is what is computed to understand how your samples are. And this is what is, this is the formula. What is the formula? Probability of mu minus sigma less than x less than mu plus sigma. Sigma is the standard deviation, how much it is away from the mean. Mu is the mean median mode because it's a normal distribution. You can take mu as the mean. From the mean, how much it is varying. That standard deviation. Within that, how many numbers are coming within this? X means how many numbers? that will become, say, from the area of the table which you consider, suppose it is becoming close to 0.7. That means the distribution is almost like this, right? That is called as 1 sigma error. It is called 1 sigma error. Now assume mu minus 2 sigma. Probability of mu minus 2 sigma less than x less than mu plus 2 sigma. So instead of taking only sigma here, you are increasing it to 2 sigma, 2 units of variation. And look at how much is coming under that. That will become, say, 9.95, 90%. Then you will say it is 2 sigma. Now assume you take 3 sigma. Mu minus 3 sigma less than x less than mu plus 3 sigma. Mu is the mean. How it is distributed? Find that area. That is, say, 0.99, 99% perfect. That's called 3 sigma. So generally what is done when you wanted to identify a product which is good or bad, it is all categorized under 1 sigma level. It is very good. Company A produces laddu, 1 sigma level, very good. That means what? 60% of the products are very good. Close to 60, 6.8 is the value. 60 to 70% say. Now assume somebody says it is 2 sigma level. That means what? Your product is 90 to 95%. In that level it is very good. Exact value you can learn, look at the parameter value and then understand 1 sigma, 2 sigma, 3 sigma, and then get to know this more seriously if you are interested. Otherwise we could again take it up and discuss again, and I will show you probably some of the figures based on your interest. Now assume your product is wonderful, very good. Then what will happen? It is 3 sigma level. What is 3 sigma level? Mu minus 3 sigma less than x less than mu plus 3 sigma. Between that, how many are there? All the products. 3 sigma level. So the distribution function which is represented by 1 sigma, 2 sigma, 3 sigma level. So you will see in management science many times people will ask for the product has to be 3 sigma level, product has to be 2 sigma level, product has to be 1 sigma level. I am sure when such distribution functions and then such explanations are discussed in management classes, when the quality control is discussed, because quality control is part of business, you will remember, oh, this is how it is. Most of the time the management students don't understand this. It is not explained well because they ignore statistics. But when it comes to application level of statistics in the business, you will find this as most essential. Many places it is used. So understand the mathematical terminology which you learn in statistics is used in most of the applications. So what is to be done? I request all of you to look at many technical terms like that and then ask me questions. Probably I can explain you in detail where is it coming from, what is the basic structure in which it is to be understood. That is why yesterday I was asking you, if you have any doubt, anything you want me to explain, you must look at it. Only one person asked what is the sigma level, which is generally asked in distribution functions. So I thought today I will explain you that, but the question itself came quite late, so I could not prepare some slide, or maybe it is not required because I find most of the time explaining you with more number of words, visualizing it is much better, and how well you draw. I told you all the time, if you are a good student, probably you must come back to me for discussions, understand or show your notes, and then see how is it you depict it, how did you learn it. That is the method in which good students have to learn, right? So only thing, what I told today is, for a best sample, mean, median, mode will be almost the same, or not almost the same, it's equal if it is very good. Okay, very close to each other if it is a good sample. That means the number of ladoos which are produced, most of the ladoos are around 50. And even if you take average of all the weight of all the ladoos together, then if something is 49, maybe something is 51. So if averaged out, it will become 50 again, right? So the average of all this, the mean, median, mode, all of them will become close to what is expected from a good producer. Assume it is varying. The variation can be learned by looking at the curve, what is called a distribution function. And that variation from the mean, x minus mu, the whole square, which is sigma square, when you take a square root of it, that is called the root mean square. When you take all the samples and then find out whether it is away from the root mean square, you can draw a curve, a line, which is called least mean square fit. Mean square. And how is it away from the line of average? And this distribution function, when you draw it, it will have a bell shape. The bell shape, the peak is very good. The distribution is very narrow. That is the best sample. If the distribution is far, the frequency comes down normally, because this, when I put it like this, the frequency comes down. I don't think there is a better method to show you other than this. So you can see. Otherwise, dynamically it is difficult to draw. Now assume that this peak, I distribute it well. Distribute it well means I am expanding my curve to the in the axis, x-axis. Then from the y-axis it will come down. Normally frequency will come down. That is what is generally called as wavelength increases, frequency reduces. Wavelength reduces, frequency increases. That's a basic physics theorem. Wavelength increases, frequency reduces. Frequency increases, wavelength reduces. So from the center, identify how much it is distributed. That is called the distribution function. How the behavior of distribution function. That will tell you the quality. That is what is generally done by describing how much it is going away. Suppose everything is very close to your mean. That means 90%, 99% is close to this. That means it is a better sample. If only 60% is close to mean, rest of the 40% is away, then it is not a very good sample. Worst sample, it is well distributed, so only 20% is there. Such samples are never even considered for quality check. It is thrown out. The list it will not be there. So generally 60% and above is considered as the best quality, right? So that is how normally a distribution function which is understood. Now in higher statistics you will learn skewness, kurtosis and such names. What does it mean? Instead of the peak like this, the peak is like this. There is a skew. Skew means it is tilted. That means all the ladoo which is created is supposed to be 50, but it became all 60. For somebody else, what happened? All that is supposed to be 50, it turned to be the other side. So everything is 40. Then how does it say? You have a skewness. You have a skewness. So there are tendency measures, probability tendency measures. You will learn what is called a probability tendency. Probability tendency, skewness, kurtosis. How it is away from the mean. How it is away from the median. How it is away from the mode. Or mean, median, mode is not same. It is skewness and kurtosis. This is how it is measured. I don't know whether it is part of your syllabus, because one of the students asked, I thought I should explain this. I don't know whether skewness, kurtosis measures are there in the syllabus or not. You should look at it. Just to say probability. That is not actually good enough to tell how much you have to learn, because probability and statistics is a big course. But normal distribution, I am 100% sure the sigma value computation, root mean square, variance, These parameters, at least you remember these technical terms, look at it, look for the explanation, look for the symmetry. It is called a symmetry. If it is well distributed, it is symmetric. The symmetric distribution is there. How well symmetric it is, how non-symmetric it is. So asymmetric and symmetric. The asymmetric will be skewness and kurtosis. Symmetric will be normal distribution. These distribution functions are useful to understand the quality of the data which you have for analyzing the statistics of the products, for qualifying to give a grade whether X company, A company is good or B company is good. Okay. Suppose you have some doubts in this, I can explain you, or maybe you want some more clarification. There is a group. I think all of you forgot that. I have not seen any comment. Probably you are busy. Much important, serious, priority things could be there. So if you want something more, you could ask me.